In section 8.2, we're going to learn to take partial derivatives, but before we do that, we need to kind of dissect how does a derivative work normally. So if we had e to the 3x power, because we're taking the variable x as our derivative and it's in the exponent, we copy the question. Normally we would take the natural log of the base, but since the natural log of e is 1, we don't need to write that. And last, we take the derivative of the exponent, and the derivative of 3x is just 3. So our answer is the derivative is 3e to the 3x. Now we do the same problem again, but instead of a 3 being the coefficient on the variable in the exponent, it's a -5. So we copy the question. We don't write the natural log of the base, but we do take the derivative of the exponent, which is 5x, to give us -5e to the -5x, and we won't worry about negative exponents. So now we're going to do this where we have two variables. We have e to the yx power, but we're going to treat y as a constant, the same way that the 3 and the -5 were a constant. So we copy the question. We don't write the natural log of e because it's just 1. Now, when we take the derivative of the top, the 3 coefficient was our derivative. The -5 coefficient was our derivative. So the y coefficient will be our derivative, and we get y e to the yx. So noticing the pattern that a 3, a -5, or a y, it didn't matter that the y was a variable because we treated it the same way as the coefficients. So as we just saw, we can have more than one variable or a multivariable function. And so now we need to talk about taking the derivative of a multivariable function, which will be referred to as a partial derivative. So the definition reads, the partial derivative of f with respect to y is the derivative of f with respect to y when all other variables are treated as constants. So it seems redundant, but basically we're saying if you want to take a derivative about x, then what you do is you take the derivative for x and you treat everything else as if it's not the variable you're taking the derivative of, which we just saw in the prior examples. Same thing, if y is also part of your input, you can take a derivative in terms of y when the derivative of f with respect to y when all other variables are treated as constants. So again, you can take the derivative of y by taking the derivative of y. That always seems the redundant part. So long as you pretend that the x's and any other letters or variables are not letters or variables, they're just numbers. So let's go into some of the notation that goes along with that. So we're going to have some function f, and we can write a derivative two ways. One is to use the symbol, which is kind of like a cursive D. So first let's go back and look at single variable. Originally, if I had a function like y equals 5x, it could have been anything. When we take the derivative, we would write dy dx. Well, now we want to use similar notation, but partial derivatives means there's other variables that could have had the derivative as the focus. So we would write these as like df dx, where we're using that cursive or script or almost fancy D. So we're saying we have an f function, and it may have lots of variables, but only x was the one we were taking the derivative of. Or maybe df dy, only y was the variable we were taking the derivative of. And same thing, all derivatives can be evaluated at some point. So we would say something like, df dx evaluated at 2,7 or whatever our values are. But I forgot, let's go back to the notation. We would have done dy dx evaluated at the point x equals whatever number we're using. Okay, so now in terms of subscripts, again, let's look at a single variable example. If we had an f function, again, let's just say 5x, when we take the derivative, we write f prime as a different notation. This is Newton's notation. So the way that we show we're taking a derivative of a multivariable function, but just about one variable, is we would use a subscript to indicate the variable. So f sub x is how we would pronounce it. Or if y was the input, f sub y. And same thing, we evaluated a point. Again, going back to the single function, this isn't a derivative, but if we were going to plug a in to a function or the derivative of the function, then we, say f of a. So in this case, we would say like f of x, f sub x, of ab, whatever the numbers are.